Good day. How are you doing today? So today I'm going to show you how to find the gradient of the tangent to a curve using differentiation. So let's just jump into some examples. So in example number 1, find the gradient of the tangent to the curve y is equal to 7x cubed plus 3x squared minus x plus 4 at the point 2 and 3. So the first thing that you want to do is to find the derivative of the y function. And so the derivative will be dy dx will be equal to 21 x squared plus 6x minus 1. So if you're new to this platform, please, I refer you to the first lesson on differentiation, how to find the derivative of the functions. Then the next thing that you want to do is just to substitute the x value. So the x coordinate of the point, that's the one that you substitute into your derivative function, and we call this the derivative function. So it's called the derivative, this one, or it's called also the gradient function. So then if you have your x coordinate, you can easily substitute that x coordinate into the derivative or the gradient function. Then you get your gradient. So therefore the gradient at the point 2, 3 will be equal to 21 in a bracket 2 squared plus 6 bracket 2 minus 1. And that becomes, this is 2 squared, it's 4 times 21, that's 84, plus a 12 minus 1. And that becomes 95. So your gradient at the point 2, 3 is actually 95. I hope that makes sense. Moving on to the second example. Find the gradient of the tangent to the curve y is equal to 2x plus 3 to the power 2 at the point where x is 2. Once again, you want to differentiate your y function, but before you do that, you want to expand this function. That becomes 4x squared plus 12x plus 9. But some people can be able to differentiate it if it's like this. But for the sake of this lesson, we're just going to expand that and differentiate it. And therefore, the dy dx will be equal to 8x plus 12. And therefore, the gradient at the point 2 will be equal to 8. Then you substitute the 2 into the gradient function. Remember, we said that is the gradient function. So then you substitute that 2 into the gradient function for x. And that becomes 16 plus a 12. And therefore your gradient at x is equal to 2 is 28. I hope that makes sense. Moving on to the third example. Find the coordinates. Now we are asked to find the coordinates of the points on the curve where the gradient is 5. So in this case, we are given the gradient. So we want to work backwards and find the x coordinate. But the first step again is to find the derivative. So dy dx is equal to 6x minus 15. So that is your gradient function. So what you're given now is the gradient of 5. And that gradient of 5 is the dy dx. So you substitute 5 on the dy dx is equal to 6x minus 15. And then you just solve a simple equation, and that becomes 20 is equal to 6x. Then your x will be equal to 10 over 3. Then after you get your x coordinate of 10 over 3, then you substitute that x coordinate into the original function. Remember, to get the y coordinate, you substitute into the original function, not the derivative function, not the gradient function. Otherwise, you're just determining again the gradient. So when you substitute that, then you get your coordinates in terms of 10 over 3 and whatever value you get after you've substituted 10 over 3 into that. I hope that makes sense. Then moving on to the last example, the gradient of the tangent to the curve 2x cubed, plus ax squared minus x plus 3 at the point x is equal to 1 is 3. Find a. So in this case, we are given the point x1 and also the gradient. So we want to find the value of a. So the first things first, find dy dx. Dy dx will be equal to 6x plus 2ax minus 1. And remember, we said the dy dx is actually your gradient, which is 3 that is given. So 3 is equal to 6x plus 2ax minus 1. And in this case, that gradient 3 is at the point x is equal to 1. So we substitute 1 for x plus 2a1 bracket minus 1. Then we just simplify that. So that becomes 3 minus 6 plus 1 is equal to 2a. And that becomes negative 2 is equal to 2a. And therefore a is equal to negative 1. I hope that makes sense. And that is how you find or determine the gradient of a tangent to the curve. You can work backwards to find the x coordinate where the gradient is given. And that's how you do it. I hope this makes sense. Have a great day further.